Nail it.
No, I took it down already.
Okay, so homework assignment was to take what we did last time, the parse and unparse. Yeah. We talked about this at lunch yesterday, so now you're just playing dumb.
He's not playing. I thought it was 350.
All right, so take our parse and unparse and make it work for lambda calculus expressions where we can have 0 or more identifiers right there. So that is, if we think about this production of our lambda calculus expressions, this production is how we take in parameters. Where's Beyonce and Paxton?
I was texting Beyonce.
Don't they live together?
Yeah.
Mm-hmm.
Beyonce, hey.
That's why.
Should I call him? Call him, like FaceTime him right now.
No. We don't need him anyways. All the important people are here now that Levi's here. Two knuckles. Only a couple of people get that. So good. All right, so we're supposed to be able to take 0 or more identifiers in there representing our parameter list coming into our production to our lambda calculus expression. So if we go back here, and we gave some names to our constructors last time, right? So we have this idea of a var expression, which is just our ID. So if we were to think about this guy here, this would be a list of var expressions, correct? That we need to parse or unparse. All right. Then we have our lambda expression, which takes in parameter and body. So this guy's going to have to be updated, right? It's no longer a parameter. Now it's a list of parameters, correct? So let's just do our initial pass here and talk about it. All right, so we're going to have to update this. Then we have our app expression. This is Rader and Rands. All right, don't need to do anything there. So we only need to focus in on when we're dealing with this second production, this guy. So now parse expression. Parse expression, when we're looking at something whose car is lambda, we're going to create a list with the string lambda expression in the first element, then a list with var expression, catter of the CAADR, the catter of a LC expression. As the second element, this is the guy that's going to need to change here, right? All right, so we need to change this, and then we can parse expression on the rest. Okay, now let me ask you this. When we're dealing with parse expression, let's just start talking about that part of it for right now. When I know that this guy is my single parameter, I know that guy's my single parameter, I'm assuming he's a var expression, correct? Could I have called parse exp on this and passed it this guy? Is this line right here equivalent to me saying parse exp on that? What's different?
No EUR, so you go through it, it does it again. But if it has more than one, it just goes through.
No, I'm looking at the old version. Old version. Is this line right here equivalent to what I just had there a second ago? So that, where I'm creating a list containing the word var expression along with the lambda calculus expression, which should just be an identifier in our old definition, is that the same thing as me calling parse expression on just this piece, which should just be a symbol? So this one piece here should come into parse expression. We should detect that this guy is a symbol and therefore create a list with var expression as the first element and then the symbol as the second. So does this produce the equivalent of this? They're the same, right? Okay, so let me go back and let's do this. So we're going to call parse exp. passing it the CAADR of LCEXP.
Isn't the reason you didn't do that last time to make sure that the user didn't have a lambda in the parameter?
Yeah, but we've said over and over again that we can assume that it's correct, but that's right. That would allow them to put things like that in there. All right, but in terms of legal lambda calculus expressions, this is equivalent, correct? So what do we do here? Well, if we're at the simpleton version, just create a var expression. Otherwise, call parse expression on the correct part. Okay? Now, right now, this guy is extracting the single identifier from our list of identifiers. So the catter there would be the list, correct? CAADR would be the car of that list, but the catter would be the list itself. That is, CAADR is that guy. CADR is that guy. Agree with that? Okay. So, if this guy is a list of identifiers, which in our new definition might have 0 identifiers in it, couldn't we call map parse expression on this guy and have it create all of our var expressions? So I could do something like this. I could map this function onto that list. Would that work? So if I had A, B, and C there, it would map parse expression onto A, parse expression onto B, parse expression onto C, producing a list containing what? A bunch of var expressions? Okay. So should this guy now handle should this guy now handle 0 or more parameters? Seemingly? Okay. What about down here? If I'm looking at a lambda expression, I'm calling my constructor, my list ref constructor. I'm sorry, list ref constructor. This gets me the specific elements. This gets me that value that is that first element, correct? We're calling our lambda expression. So really, this guy right here this is the list of identifiers, correct? Actually, I've done this incorrectly there. Yeah, okay, so I took off one level, so now we're back to having our list of our identifiers rather than just the identifier itself, right? So I'm calling my constructor for our lambda expression, which before just took a single identifier. Now I'm giving it a list of identifiers. Go ahead.
So when you unparse it, doesn't it give you it says var expression and then the E or whatever, then the variable?
Yep. All right, so this is going to be my list. So again, on our unparse expression, what we had before was just getting me this part. Now I'm saying give me the list of those. Okay? And this is where it's actually calling upon our lambda expression constructor, this guy up here, that we already said needs to change. So this is no longer param, now it's params. Okay? Maybe call it params. And params takes in, well, what we're doing here is we're taking in we're building a list out of those params, correct? All right, but right now we're taking in a bunch of var expressions. Isn't that what this guy would be? Wouldn't that be a list of var expressions in unparse? Okay, so if this guy's taking in a list of var expressions, so in order to create a lambda expression, I need to pass it a list of the parameters, and my body, which is going to be a lambda calculus expression, right? So here's that lambda calculus expression. And what am I doing down here for that? I'm calling unparseexp for the body. But we have an issue here. This constructor expects me to give it a list of identifiers. So something that looks like this. Not something that looks like var exp a, var exp b, var exp c. Doesn't expect that, it expects this. But what I'm currently sending it is something that looks like that. Correct? Assuming I've built my stuff up the correct way. So how do I turn this into this? Well, when I call var expression, passing it an ID, it gives me just the ID. What do we do in unparse expression when we're dealing with a var expression? Well, we're dealing with a var expression, sorry. We call our constructor passing it the actual var. So instead of calling instead of passing this guy in directly, don't I want to map unparse exp onto this list of var expressions? Make sense? So it's going to go both ways. So let's look at how this is supposed to work. Oh, wrong direction. So let's do x, y, z is my parameters here. Okay. And then let's go ahead and let's call parse. What do I call it? Parse exp? Parse exp on an exp. Oh, did I break it? There's that. Then there. Okay, there. Now we're good. Map that onto that for a lambda, except that's not the end of lambda. That's the end of, there we go. All right, and then this is our, I changed it there, but I need to change the name here. But right now, this guy is already a list, correct? So this is just params. Not a list of params, because I'm passing in something that looks like this. Question and answer if it's found. All right, so if the car of it is a lambda, then create a list containing a lambda expression. All right. So let me quickly do this and exp, and let's dump these couple of things here and run it. So this is our original. We have a lambda that has 3 parameters, x, y, z, and whose body is just our app expression. And this is going to create a lambda expression which contains, here's our parameter list right here. That's a list containing a var expression, a var expression, and a var expression. That look accurate? Okay. And then whose body is going to be our app expression containing a var expression and another var expression. All right. And then unparse exp, passing it the result of parse exp. We'll just call it again. This isn't efficient at all, but whatever. Should give us back our lambda list xyz list ab. That's the result of calling unparse on parse. That makes sense? All right, so would you say this is a pretty good use of map? Now, so out of curiosity, how many of you used map? Okay, 1 1/4 people. Okay, so most of us didn't use map. So now, how many of your solutions support 0 parameters?
What's the optimal output for zero? Like, what should it put out instead of? Like,
okay.
if it just had an empty list. Does that count? Is that cool?
Yeah. So if we have 0 parameters here, just like that, right? Okay. So does yours work for 0 parameters? Well, you used map, right? So map should auto work for 0 parameters. If you didn't use map, you kind of had to make it work for 0 parameters, correct? All right, go ahead.
What I do?
Yep, tell me what you did.
I created helper functions for to parse multivar and then unparse it. And then
And how did your helper functions work? So you pass it the list of
passed it
vars.
the list of vars, and then for parsing it, I cons the list of var expression, the list of them var or var exp.
So you passed it this.
I passed it that, yeah. And then inside of it, if it was null, I returned the empty list. Otherwise, I cons.
So that was your that was your check to see if there was no parameters. No parameters, don't do crap. Here, don't do crap. Yeah, don't do crap. Here's the empty list, fine.
Otherwise, then I created a list that contained var exp, just like the words not creating one, of the car of the v list, and then I cons all of that onto the parse multivar of the footer of the v list.
Okay. So you basically built a specialized map that only works for that exact thing. Okay, fair enough. So now those of you, well, most of you did not use map. Why is that?
I didn't quite understand it, so.
Usually forget about it until you do it in class.
Oh,
I didn't use it because I didn't want to use the parse that we had already written, because I thought we were supposed to exclude them from accidentally passing lambdas.
okay, which is fair enough. So if we are making, so what he's indicating here, which does support our grammar, this guy here does not say lambda calculus expression in our grammar. This guy says identifier specifically. Okay, that means it has to be an identifier, not any one of these, including an identifier. Okay, so that would be more correct. Treating this as a special type of animal as opposed to any old lambda calculus expression. All right, so realistically speaking, you choosing not to use map was probably, from a language development perspective, more correct than us using map as a shortcut. Does that make sense? Because specifically what this guy says. We should not be applying parse expression to this guy because this guy is not a lambda calculus expression. And he's not a list of lambda calculus expressions, technically. Right? Which also then means that technically he should not necessarily look like this. Those guys are not var expressions. But my guess is your code displays them as var expressions, right? All right. So choose which side you're on, right? So you either treat these guys as lambda calculus expressions, or you treat them as the grammar dictates that these guys are just plain Jane identifiers. They just happen to look kind of like production 1 of our lambda calculus expression. They look like it, but they're not one of those. That makes sense? So if that were the case, what would we modify up here? So inside of parse, we're currently mapping parse expression across this guy. What does this guy look like? Just XYZ, list XYZ. So really, this guy would just look like this. And this guy down here would just look like that. And then this guy up here will look just like that. So now it's a list XYZ here, it's a list XYZ here, it's a list XYZ here, it's always list XYZ, no var expressions. So this would probably be the most accurate based on our given grammar. Does that make sense? All right, so out of curiosity, I'm guessing the answer is nobody. None of your outputs look like this, correct? Every one of you treated these as var expressions. Whether we read them in as only being allowed to be those identifiers, or whether we read them in and treated them like they're any sort of lambda calculus expression, and let's just hope they didn't cheat. Okay, so my version is hope they didn't cheat, but we're going to treat them as var expressions. His version is assume they might cheat, but still treat them as var expressions, when the reality is the book would dictate that you can't cheat because those guys are not lambda calculus expressions.
I have what you had there on the.
Okay, so we're all wrong, is what you're saying.
No, I'm just saying that's what I had.
What, mine?
No, the one. If you go back to your scheme, Dr. Rackett. Yeah, that's what I had. When
Your
you said-
output's like this?
Yeah.
Oh, so yours is correct.
That's what I had.
Oh, so you did make them var expressions.
I did. Or
You
I?
didn't. You did not make these guys var expressions?
Individual var expressions?
Yeah.
No,
Why not?
because the grammars call for an identifier.
So you're the only one who did it right.
I'm not saying that everybody else did it wrong.
Do you
I'm just saying
suspect
what I
that's a
did.
true statement?
I don't know.
The answer is yes.
Relatively unimportant how you ended up doing it, as long as you kind of did something in the vein of what we're trying to do here. But understand that this is what the grammar says. So reading grammars is very important. So just because that guy matches one of our productions of a lambda calculus expression, he is not a lambda calculus expression. Therefore, production 2 here, the version we were writing this for, would probably say open parenthesis identifier star, close parenthesis, 0 or more identifiers, as opposed to 0 or more lambda calculus expressions. That makes sense? So if we're grading this in binary, Jake gets 100, everybody else, including me, gets a 0.
That's why we don't grade in binary.
That's why we don't grade. Oh, 100 is not a binary number. You laughed at that. You're
I would
still
get
wrong.
I would get a 1 and you guys would get a 0.
I guess it's better than that. It's only 1 point assignment.
It's
1 out of 1 points.
All right. So kind of makes sense? All right. Now, let's go down here. That's occurs free. I want to get to apply. Yeah, let's just write it before we look for it. This will be more fun. Okay, so we're going to say this is the correct version of it right now, correct? Okay, so we have, no matter which version of our output we're looking at, whether it's the parsed or the unparsed, we're always looking at a list of identifiers. Okay, that's what our constructor takes here, and that's what our symbolic representation looks like here for our parameters. Okay, so now we're going to write a, let me open this guy up. Were we supposed to have a quiz today? All right, good. Did you even wash the Mountain Dew out of your hair? Diet Mountain Dew. That's got weird syrup. Still absorbing. All right. So let's talk about apply-exp. Okay, so apply-exp is the, let's say this guy this applies a lambda calculus expression use enough R's it forgets about it. It's like, I don't know what to fix that. Okay, applies a lambda calculus expression to the proper number of parameters. All right, so for example, back here, if I've defined a lambda calculus expression like this guy, how many parameters does that guy take? 3 inputs. Here's the input to my function. So if I were to apply this guy, I would have to pass him 3 values, right? So if we're doing this in real scheme, so let's say I did a, let's say I have a lambda x, which just boils down to x, and I do that, what should the output of this program be? Is this a lambda calculus expression? How many parameters does he take? How many parameters did I give him? 1. So I am applying this guy to this parameter. Let's do xy plus xy 5, 7. Here's my 12. Here's my function. Takes 2 parameters. I'm applying it to 2 parameters. Based on what you know right now, what would you call that expression? What kind of expression is that? Break this down and tell me what I would get if I called parse expression on this guy. What's that? Okay, so that's a lambda calculus expression. Specifically, it's production 2. Right? Production, it's an app expression. Yep, this guy's an app expression, or he looks a lot like an app expression. Okay, so this is lambda calculus expression. Here's the list of identifiers. Here's the body. So this is another lambda calculus expression, right? What kind of expression is this one? What kind? That guy is supposed to be a lambda calculus expression. Specifically, what kind of lambda calculus expression is that?
Would be the third grammar.
Yeah, an app expression.
Operator and the operand.
Yep, this is an app expression. This is the rater and the rands. Okay, and what are the rands? Those 2 guys. List of those guys. This is the rater. This is the rands. Make sense? Go back here. Scroll up to the definition again. This guy says that our third production is a lambda calculus expression followed by a lambda calculus expression inside of a list. The first guy was our lambda expression, so that is the first part of it. The second guy is a lambda calculus expression, right? And what kind of lambda calculus expression is it? Well, it's a list containing 2 identifiers. That's the type of lambda calculus expression we currently have. Correct? Okay. Go back here. Apply this to 5, 7. Does that look like our app expression, lambda calculus expression now? So that's what we're trying to mimic, right? Here is our rater, which is a lambda calculus expression. Here is our rands, which is a lambda calculus expression. Specifically, the rands is an app expression, which is a list containing an identifier and an identifier. All right, so apply, that's built into Scheme, new magic trick for us. I don't think we've actually used it at this point. You've probably seen it, but I don't think we've used it. Well, now we have. All right, says we're going to apply this lambda calculus expression. More than likely, it's going, things that we can apply our production to, right? The functions. So apply this function to this correct list of parameters. If I reduce this and say I'm only going to give it a one list, it's going to scream at me, expects 2 arguments but only found 1. I didn't give it enough inputs. That make sense? Similarly, if we say x, y, z here, and I pass it 5, 6, 7, I get the 11, 5 plus 6, the 7 came in, but we didn't do anything with it. But now, if we think about this, that guy, what production is that? Is that a lambda calculus expression? By this guy back here, he's supposed to be. This guy says production 3, the one this guy looks the most like, right? He's not just an identifier. He's not a list that starts with a lambda, so he must be this guy if he's anything at all, right? And this guy says he's a list containing a lambda calculus expression and a lambda calculus expression. Is this a list containing a lambda calculus expression and a lambda calculus expression? What is he actually? It's not a trick question. He's a list containing a lambda calculus expression, a lambda calculus expression, and a lambda calculus expression. 3 of those guys. Now, does this seem legit? Did it work? It did something that seems like it was something it was supposed to do, right? So something like this should probably work. Is this kind of like what we were just talking about with our number of parameters? Where maybe this aspect of this production needs to be a little different. 0 or more lambda calculus expressions inside of a app expression, this third production. We're kind of foreshadowing, looking ahead where we might be going with this. If this guy is likely a lambda, or production 2, if he's likely one of those guys, might this guy take in, by our new definition, 0 parameters? Sure. If he's expecting 0 parameters, what would I be passing him there? Nada.
In the second one, we just pass how many identifiers there are.
Well, correct. I mean, so when we try to apply this guy to this guy, we should expect there to be 0 or more of these guys here. So there might be 1 lambda calculus expression, there might be 0, there might be 5. The number of things here should be equal to the number of things that were here for this guy. That make sense? So, I mean, that's I'm not saying we're writing this part yet, but that makes language sense, correct? If I have a function that takes 2 inputs, I need to provide it with 2 parameters. We have raters and rands. I have to provide it with 2 operands. If it takes 4 parameters, I need to provide it with 4 operands. If it takes no parameters, I have to provide it with 0 operands. So if we say that this guy is our operands, that guy ranges from 0 on up in real programming languages. Fair enough? Okay. Now, what we're going to do is we're going to, let me go back to here, we're going to write apply expression. This applies a lambda calculus expression to the proper number of parameters, which means now we need to make sure that rands contains the same number as length of params. So if I'm taking in an A, B, and C, my third production of the lambda calculus expression must have a lambda calculus expression, guaranteed one lambda calculus expression. So this guy here is not 0 or more. This is 1 every single time, 1. But this guy here is 0 or more. That is, he must have a number of elements here equal to the number of identifiers in the parameter list of that guy. Make sense? All right. So, having said that, let's go back here. And I, really just leave this alone for right now. No, I want to re-break it. So I'm going to go back to this. We're going to turn this back into a param. Okay? Because I'm going to write the easy version and give you the hard version for homework. Okay, so this guy's going to be a param. There's a lambda. And this guy's going to be a list containing that param, right? Actually, we'll make it somewhat easy. I'll leave it like that, so param to param. So I'll just pass in the list like we're almost doing now. Well, realistically speaking, then, I don't even need to break it. I'll leave it alone, but I'm not going to pass it more than one parameter, or less than one parameter. I'm passing it exactly one parameter. Okay. So now, what we want to do is we want to define apply exp. Okay, and apply exp is going to take in a parsed he's going to take in a parsed version of our expression, so something that looks like this, and he's going to evaluate it. Fair enough? Okay, so apply-env. Usually we write a couple different things here. We write apply-env and we write eval-env. Let's just start simple. We'll just write apply-env. We'll break it up when it makes sense to do that. So apply-env is going to be a lambda that takes in a lambda calculus expression and possibly something else, maybe an environment. Okay. And what does he do? He's going to execute this lambda calculus expression in terms of what it says to do and the environment right here. That make sense? Okay. Now, do we still have our stuff for our environments? We do not, and that's okay. So what we're going to do here is we're going to rewrite our environments real quick. So let's define empty env to be a lambda that takes in no parameters and boils down to what we have, that the empty list. Define extend env. Didn't I really like the scope? I like the scope implementation of this, didn't I? All right, so let's take in, so let's do define empty scope. And this guy will be a lambda that takes in no parameters and returns the empty scope. Then we'll say define extend scope to take in a lambda, or to be a lambda that takes in a var, a val, and a scope, right? And this guy will cons the list of var val onto the scope, like that. So a scope is going to be a list of two lists. I think that's what Amish had, right? Scope is a list of two lists. So we'll create a list out of our var val pair, and then we'll cons it onto our running list. That's our scope. So that's our extend scope. And then we'll do define extend env. And this guy will be a lambda that takes in a scope, takes in a scope and an existing env. And what he does is he cons the scope onto the env, like that. So we have a list of scopes where each scope is a list of two lists. All right, good. Now we have an environment. So having said that, let's go down here and I'm going to come back to this here in a second. Let's just define some stuff here. So I'm going to say define exp, what is it, and exp, to be a lambda ab I'm going to write the whatever, it's fine. Make it a simple one, since we don't technically have like math operators and stuff like that. That's coming, okay? So that'll be our expression. And then we're going to do a define env to be a, let me start with empty env. An empty env is going to take a, we're going to say extend that empty env with a extend scope with a, let's say A1 onto empty scope. And then I do have to admit, my solution for this was a lot easier to add more variables. I think my solution was have two parallel lists, right?
Yeah.
Yeah, that would have been a lot easier to add the variables, but I really like the scope approach to this. So
Doing with the A1 there.
this is going to be a,
Yeah, 'cause it's in post.
var val. Yeah, thank you.
You put the A, put a
Yeah, we do. It's got to be quoted. Thank you. All right, and then we'll say extend scope B2 onto this scope. And let's kick this down. And let's kick that down. There's that. And then we'll say, I only have two, right? A and B, that's all I need? Yeah, good. So I'm going to extend env. Here's a new scope. And the environment I'm extending is the empty env. Like that. Yeah, ish. All right, so now I have, basically I have a single scope. That is the extending the empty scope twice. We take the empty scope, we add a variable A1 and a variable B2. B equals 1, or A equals 1, B equals 2. Onto that guy. All right, so now I have an environment in which to execute this expression. So my output of this guy should be ultimately what? The list 1, 2. When I evaluate the expression A, it would boil down to me looking up A in my environment, right? Okay, and what was that function called? That was called what? Apply-env. Apply-env took in a parameter, took in a variable name, and went and looked up the value or returned false if it didn't find it. Okay, so, and I do like this scope. It really sucks to hand add variables using the scope data structure, but later on when we define variables and have it automatically added, it's going to be programmatically very effective. But this version of it completely sucks. So your solution is horrible for humans. Completely horrible for humans. All right.
Yeah, I'm just like do things the long
We like
way.
do things the long way, right? All right. So we're going to say define apply-env. And this guy is going to be a lambda that takes in a var name as a parameter as well as the environment, right? And what this guy is going to do is he's going to look for that var inside of the environment. Okay? So, if the environment, which is a list, if that guy is currently the empty list, so if null env, then we can boil down to false. Otherwise, we want to apply, you know what? I'm going to do this inside of a cond. Null env, boil down to false. That means we're out of places to look. Otherwise, we know we at least have a car to this. And the car to this guy should be a what? Ultimately, after I've extended my environment, I'm left with a list of scopes, correct? So when I think about this env, what it actually is, the type of animal this guy is a list of scopes. So if I'm out of scopes to check, return false. Otherwise, we're going to check our apply scope, the car. So we're going to define another function here, define apply scope. And this guy takes in, he's a lambda that takes in a var and a scope. Lambda. All right, and ultimately he's going to, let me just close that guy real quick there. All right, so this guy is going to take in a var and a scope. So when we come here, we're going to go ahead and we need to check to see, and we'll do this the non-let way for right now. So we need to check to see if we actually got a value out of that or if we got a false, right? So if not apply scope, passing it var and the car of env, the current scope we have available to it, if that returns false, okay, if that returns false, then what are we going to do? We're going to call apply-env on the cdr of env. Make sense? So, if I checked the current scope and I did not find the value in there, that means this guy returns false. Well, we have to make sure he returns false up here. Then I'll call apply-env, this guy, passing it the cdr of the environment, that is all the scopes except for the one we just checked. Okay? Else, we'll just recall our apply scope because we know we actually found the value, right? And that'll boil down to the value. So really, we should probably implement this guy inside of a let so we can hold that value and not have to call the function twice. But right now, we'll just let that slide. Okay, so that's apply-env. So now we need to write apply-scope. So apply-scope's going to take in our var, take in our scope, and this guy's just a list of two lists, right? That's your implementation, list of two lists.
Yeah.
All right, so we're looking for this var to be the car of one of those two lists. All right, so we'll do a cond, because I just like the cond structure. Cond, and we'll say if null scope, boil down to false. Otherwise, if car, well, so otherwise we're going to say, we're going to take the car of the scope, which should be a to list. We're going to take the car of that to list, which should give us a variable. We're going to check to see if that variable is equivalent to the var we're looking for. If it's true, then we're going to return the so this is the CAA. Let's write this shorter. CAAR of scope. All right, so if the CAAR of scope is that, then we're going to do the CADAR of scope. That'll get the car, then that'll get the cdr as a list, and then get the car of that, which should be the value. Okay, so the cadr of scope should be the value associated with that var if we're looking at the correct var. Else, we'll call apply scope, passing it the same var and the cdr of our scope. Like that. All right, make sense? That's apply scope, that's apply env, blah, blah, blah. All right, let's test this real quick. I'm sure it's perfectly written code, but worth testing anyways. So let's call apply-env, passing it a variable. So let's pass it an A along with our environment. So this should give us a 1. Not. Oh, I think we need to say not number, right? Otherwise we're trying to, okay, so we need to say not number of this guy. See, I was testing, you guys didn't catch that the first time around. So.
I did, I didn't say anything.
Really?
Yeah.
All right, so there's our 1 for apply A. Let's get our 2 for apply B. And let's get our false for apply C. If null env, so that last time through, was it a list? So I passed it the same var, and I passed it the car of the env. All right, so this last call has to be wrong. Okay, so if we're out of stuff to check, do that. Otherwise, if it's not a number, call that. otherwise apply scope, passing it the var, and should be the exact same thing we had before. All right, so I'm looking, so I have a scope. Okay, so env, the guy starts off, let me print out. Right. So here's my list. It's a list containing, so this is my entire environment. And that entire environment contains a scope, that's our scope. And that scope is a list of two lists. So very first time through, I call apply-env, passing it C for that, and passing it this guy for our environment. I ask it, are we out of crap to check? No. Okay, so I have environments to check. Then I'm going to call applyscope on the car of env. That's this guy. That's the car of it. Passing it the var, so C, and the car of env, so that's this guy up here. If I'm out of stuff to check in there, I'll return false. Otherwise, if the car of the car, that is, here's the car of that guy is B, if that guy is equal to our var, which it's not, then return the value. Else, we're going to apply scope, this thing, same thing, passing it our same var, passing it the cooter of our scope. So here's our scope right now. The cooter of our scope would be the list containing this guy. So then I'll ask, is the car of that equal to C? It's not. Therefore, I'll go to this. I'll call apply scope on the empty list, which then says, is the scope currently null? It is. I'll return false. So this boils down to false here on apply scope. So since that guy's not a number, oh. Else if he, okay, oh, so if he's not a number, so that'll boil down to false right there, correct? Which is not a number. So I should call apply-env. Oh, I just didn't pass it the var. I should have read it expects two arguments, but I only passed it one. I have to give it the two arguments that it expects, right? All right, there we go. So there's our false. Aye. Okay, so now we have a working environment. Assuming it perfectly works, right? Let's just run with that. Okay, so now that we have an environment that we can apply, that means we can look up values in, and we have an expression that we want to call applyexp on. And for our little expression here, I'm going to just take in a single value. So I'm going to create a simple little expression. All right, so what I want to do is I want to write apply expression. And this guy's going to be a lambda, and he's going to take in an expression and an environment in which to apply that expression. All right, and he's going to have a cond, and this cond is going to say if, and this guy's going to be a parsed. He's going to be a parsed version of our expression. That is to say, he'll have things in it like the string var exp and the string lambda exp, telling us which of those productions we're looking at. All right, so cond, we're looking at our expression. All right, so we're going to say, well, we probably can do null expression. That means we're done, correct? So let's just do null. Actually, I don't even think we need to check that. We'll come back to that. So if the car of our expression is equivalent to a var expression, because we wouldn't be calling apply-exp unless we were dealing with a real expression. All right, so if the car of our expression is a var exp, that means we're looking at an actual variable, then what are we going to do? We're going to call apply-env on the variable name, which is going to be, what does our var expression look like? It looks like var expression, so it's the catter that is the actual value. That's the actual variable name. Var expression, variable name. So this guy will take in, where am I? I'm lost. Scroll, just keep scrolling until you find it. All right, there we go. Found it. All right, so I'm going to take in the catter of expr along with the environment I want to look it up in. Okay? And this guy should boil down to, for right now, let's just assume any variables we use are in existence. Okay? So if I'm looking at a var expression, boil down to the value of that var expression. Okay? Otherwise, if I'm looking at a, what is that, lambda exp? If the car of my expression is a lambda exp, and a lambda exp looks like this guy, looks like this, then he has some parameters, right? So that's what our parameters are, parameter list right there. And then he has values. Now, what should I be doing with this parameter list right now? You know, parameter list isn't going to have values. Parameter list is going to have variable names, right? Okay, but now we have an issue. How did these variable names get into our list of values? So let's come down here. So just to kind of put this all on, let me press enter here a couple times. Let's just put that off. Here's my initial expression. Here's my initial environment. I hard-coded these values into the environment. But how am I going to actually use apply expression? I'm going to use apply expression like this. So, yeah, apply exp, passing it an exp, and passing it an environment. Say this again? Yeah, I am. Yeah, just assume this is. You're right. I need to call parse expression this guy. So we'll write that. So parse exp on an expression. So now I get the parse version of that. All right. Now before we were looking at apply expression, and apply, when we look at the scheme version of apply takes what? A lambda calculus expression, so like a lambda. So for instance, I can say apply add, which is the plus sign, to, let's keep it simple for us, 1, 2, something like that. Oh, that's just still broken up there. Let's,
You can write it down below.
that gets me the 3. So apply expression takes in a lambda calculus expression and an app expression. This guy is an app expression. Where did my environment come from? I've hard-coded an environment in here, but for this to work, shouldn't I call apply on this guy along with the parameters? That is maybe 4. An expression takes in a single input. I'm going to pass 4 in for that input. Actually, this is going to be a list 4, like that. I'll pass 4 in for that input. It will then add that 4 coupled with A to an environment, i.e. extend an environment, with and then resolve it inside of the body of that lambda. Does that make sense? So really, my starting environment here should start off as just the empty environment. That gets the ball rolling. Here's an environment with nothing in it. Here's the lambda expression. Here's the parameters I'm giving you. Do what you must. Does that make sense? All right, so let's see, we had 20 or 25? Okay, so we're still good. All right, so given that, we need to come in here and we just say env is just empty env, like that. And get rid of the second line here that's broken. So now when I call apply env, when I'm dealing with this guy right here, when I'm dealing with a lambda expression, that is, I have this guy and I get this local environment, a local scope. So we think about this in terms of Java. Whenever I have a method, I get a local scope with that, right? Okay. And what does that local scope do? It's going to define some variables that are available in the local scope. So I can probably extend my environment with a scope, right? With those variables already in there. But do those variables have values yet? When do those variables get values? Parameters don't usually get values in the body. And our language right now doesn't support us defining variables. The only way we can use variables right now is through the parameter list. When we have a function in Java, when does that function, and let's say the function takes in 2 parameters, when do those parameters actually get their values? When we call it. That is when we apply the lambda calculus expression, production 2, apply that function to the values that we're passing into our environment, right? Now, the variables already exist. The scope exists. I'm going to have a variable here in my environment named A. And that variable right now has no value. Does it? But it will. Or at least it better. Okay? It has to have a value in order for me to apply the expression that is the body of that lambda calculus expression. That means I need somebody to pass me the value that I need to then actually associate with my local scope. Does that make sense? So I kind of need to pre-create my scope so that I can actually extend my scope later on. How would I do that? As I'm going through the code right here, if this is what I'm passing in, I'm passing in I'm calling apply-exp, passing it the parsed version of my expression, as well as the values that are going to be associated with that, as well as our environment, env. That's the environment in which it's being applied. Where do these guys come from? Yeah, you want to have another parameter up here, right? So here we'll do, let's call this params. How do I get these params into this environment? Okay, so I have these parameters, and I can extend the environment, or I can choose not to even take in an environment and just assume it's the empty environment. Probably makes just as much sense, right? But do I know what variable names to attach it to? How do I work with this? We certainly got to do something, right? Because right now I have a 4, and a human being can look ahead and say, oh, I'm eventually going to have a variable named A that's going to have that 4 stored in it. But right now I have the 4, and I have no idea about the A. The only reason I even know about that is I've looked. The human eye has looked up and seen that we have a variable coming soon-ish. Soon-ish. So I need to have some way of getting that 4 into that thing. Go ahead.
Could we create a stack so like the 4 is on top and then every other one, or like the 4 is on top, and then when you first meet a variable, you assign them to each other? Like the A is then the 4, and then if there were other ones,
Okay.
B would be the next one in it.
The real issue here that we'll have to look at next time is when do we call apply-exp? When do we actually call apply-exp? We only call apply-exp when we have a app expression. Only when we have our production, a third production that's an app expression. We don't just call it out of the blue. So we might have something called process expression that goes through an expression. And then as we hit an app expression, we call apply-env with the left-hand side, which is going to generate an environment, and the right-hand side, which can augment that environment with the values. All right, so we'll look at that next time, and I'll give you your homework assignment then. No homework? But this weekend,
This weekend is
the hellish